Hey, good afternoon, class. And I am in South Dakota doing a little hunting, and we'll be back tomorrow, if that is, you're watching this on Monday. Looking forward to seeing you Tuesday in class. Until then, this is the first of two videos, or most likely this will be the only video. Let's go with that. And so there's two activities for today. The first one I'm going to make a video for. The second one we will do in class on Tuesday. So we'll use a little bit of the class time to do that activity along with a frappy or a FRQ from a previous AP exam. Let's take a look at this activity. Does caffeine increase pulse rate? And Ms. Gallus and her students decided to perform the caffeine experiment. In their experiment, 10 student volunteers were randomly assigned to drink cola with caffeine, and the remaining 10 students were assigned to drink caffeine-free cola. Were their findings statistically significant? The table shows the change in pulse rate for each student, final pulse rate minus initial pulse rate, along with the mean change for each group. So what they did is they measured each of the students who took the caffeine, final pulse rate minus their initial pulse rate, and here are the 10 differences. It has a mean of 3.2. The other 10 students that did not have caffeine, they took an initial pulse rate and a final pulse rate, found the difference, and that mean or average is 2.0. Therefore, in question 1, it says find the difference in mean pulse rates for the groups. Does your initial reaction lead you to believe that they found evidence that caffeine does or does not increase heart rate? Explain. Well, 3.2 minus 2 is 1.2, so there is a mean difference of 1.2 beats. 1.2 beats to me is not that big of a difference. So I am not convinced that there is a difference due to the caffeine. Now, what are two possible explanations for the difference in mean pulse rates? And this is what we're trying to get at. This is the inference that we're going to be performing a little bit here in chapter 4, and then much more when we get to term 2 and some of the later chapters. One possibility is that caffeine caused the change. The other possibility is that the larger mean for the caffeine group was due to coincidence. And we call this chance. By chance, those people ended up with a higher mean average, or a higher average. So we're going to try to decide if the difference in the pulse rate is big enough to be convincing. Therefore, we're going to perform a simulation. The simulation, I didn't do it as they described. I did a little bit differently. And so that you understand what we're talking about, I assigned each of those students a number 1 through 20. And then I did a random number generator on my calculator, ignoring repeats. And the first 10 numbers that came up, they were, in my first simulation, right here. Those are my first 10 numbers that happened to come up. Then the other values, or other students' caffeine pulse rates difference, were assigned to the no caffeine group. I did this 20 times and found the mean for the caffeine group, the mean for the no caffeine group, and then I found their difference. The mean in this first one, I believe, was 2.3 for the caffeine and 2.9 for the no caffeine. I then subtracted those and got a negative 0.6. And I did this 20 times. And here are my 20 simulated samples. A negative 0.6, like I just showed you, and then 2.0, 0.8, so on and so forth. I then made a dot plot of those differences. And I should have labeled this as the difference in mean pulse rates. This blue line represents the 1.2, which is the mean difference we found in the study that Ms. Gallus and her students were doing. And then everything to the right of that represents 3 of my simulations that had a higher difference in mean pulse rates. And those differences, I think, were 1.8, 2.0, and 2.2. Each one of these dots that you see here represents the difference in mean pulse rates if the caffeine has no effect. And that's the key piece. We are going with, and I'm going to go back a slide or two. I can't in this, I'm sorry. But if you go back to that second question, it said, just hang on one second, what are 2 possible explanations for the difference in mean pulse rates? And we said caffeine would cause the change. And then we said it was basically coincidence, or that it happened by chance. Well, that's what we are assuming. We're assuming that caffeine has no effect. When we get to the later chapters, we're going to call this the status quo. We would expect no difference. And that's often called the null hypothesis. So then question 5, it says, what percent of dots are greater than or equal to the difference in means of 1.2 found in Ms. Gallus' experiment? Now, that's where I drew the blue line. And the difference, or the number of dots to the right, was 3 out of the 20. That corresponds then to 15% of our simulated samples had a mean, or a difference in means, of 1.2 or more. So if we want to interpret this, assuming caffeine has no effect on pulse rates, there is a 15% chance of getting a difference in pulse rates of 1.2 or greater by chance alone or by coincidence. Do you think the difference in means we found from our experiment is due to the caffeine, or has it occurred purely by chance? Well, for much of our work, we're going to be using a 5% rule, or a 5% mark. So statistically significant is if the probability, or the percentage, is less than 5%, meaning it's pretty much unlikely for something to happen, and so results are due to the treatment in our experiment. Now, if we have a percent that's greater than 5%, that is not statistically significant. This is not that unlikely. You could say, well, what's the difference between 6% and 4%? There isn't that big of a difference. Well, this is just kind of a measuring stick that we use. And sometimes it's going to be a little bit smaller than 5%. Sometimes it's going to be a little bit bigger than 5%. And we'll get into that later. But it's just, it helps right now for us to get rid of a little bit of the gray area. So if something is less than 5% chance of happening, then we have something that's statistically significant. And we think that the results are due to the treatment. But if it's greater than 5%, as an hour simulation, we would not have enough evidence to conclude that the difference in pulse rates is due to the caffeine. Now let's take a look at the big ideas. Oh, one other thing. If you need to go back or pause this so you can get caught up with the writing, please do. Big ideas, sampling variability. We'll get into that with the check your understanding. take some time, if you haven't read about that in the book, to please do so. So sampling variability, one thing about it, different samples yield different estimates. If we were to perform this simulation, and you can take a look at all those differences that I had on the previous screen, each simulation or each sample simulation that I performed came out to be a little bit different. Well, not all of them, but they had different groups of people or different groups of students, and that produced a different mean. Number two, larger samples produce more accurate results. If I'm taking a sample, let's just say there's 4,000 students that was at high school, and I'm going to take a sample of 100 and find out what their favorite movie is. Well, that might give me a pretty good estimate, but on which movie is most liked by students. But if I was to sample 1,000, that might give me a little bit better estimate. And if I sampled 2,000, half of the students, that'd even be better. So the larger our sample, the more accurate our results will be representing that population. And then number three, margin of error. It creates that interval of possible values. So if I have my sample estimate, and maybe we take the population of Wayzata students, and we're going to measure the mean height of all students. Well, that margin of error is what we call casting an umbrella. And within that umbrella, we would expect to find the true population mean height. Now, what is statistically significant? Well, we just talked about that also, when results from a study are too unusual to occur purely by chance. So we create a simulation, there's our dot plot, and we take a look at the points, number of dots to the right of what our sample produced. And the proportion of dots that are less than 5%, that would be statistically significant. And if the portion of dots is greater than 5%, it's not statistically significant. Now, what I'd like you to do here is to check your understanding. Pause this, go and answer the four questions dealing with NFL players' weights, and then resume playing. So pause it. Welcome back, and hopefully you completed this. I'm not going to go through it. You can kind of read through the questions and my answers to those questions. I am going to just highlight one piece, part, I guess it's the first one. It says, do you think that 244.4 pounds is a true average? Explain your answer. No, it's one sample. Now another sample, and this is key right here, of the same size. We can't say, well, we're going to take 60 NFL players this next time. It has to be the same size. And it has to be from the same population of NFL players. May produce a different average weight. It may produce the same, but it may produce the same average weight, but using a different group of 50 players. So go ahead, read through. I will be back in school on Tuesday, and we will wrap things up with the other activity Tuesday, along with a Frappy and or a FRQ. So Tuesday will be a little bit busy. Plan on going the entire class period. Have yourself a great afternoon. And those of you who are not doing the homework, please do so. Homework participation percent has dropped significantly. And chapter 4 is one of the most important chapters. You will see an FRQ dealing with the concepts from chapter 4, along with probably somewhere between 5 to 8 multiple choice questions on these topics, maybe even more. So have yourself a good afternoon. Take care, be safe, and see you tomorrow.